Number 1. The helium-3 that doesn't belong here. Helium-3 is considered one of the most valuable treasures of the Apollo program. Instead of rocks, this invisible, stable isotope was the grand prize. While it is rare on Earth, where it is artificially formed from the decay of tritium, it is highly concentrated in lunar regolith, a product of solar wind particle implantation. Its significance lies in its potential use as a fuel for cleaner nuclear fusion, a future, clean energy source that produces negligible radioactive waste, making it a strategic target for missions like Artemis, with estimated quantities of at least 1 million tons. Surprisingly, it wasn't its mere presence, but rather its distribution and isotopic composition that were baffling. Instead of random scattering, its concentration was particularly noted in the Maria regions rich in the mineral ilmenite, which effectively absorbs it. Furthermore, the measured helium isotope ratios did not exactly match familiar solar models, suggesting the atoms underwent an unknown transformation process in terrestrial physics, perhaps due to previously unrecorded solar or cosmic interactions. A NASA scientist described it as a solar reactor operating on strange settings. This physical enigma is currently driving efforts toward developing space mining techniques to extract helium-3 as a vital byproduct when harvesting water and oxygen from the regolith, confirming that the Moon offers us a material that exceeds the limits of our current physics, holding the key to a future of clean, sustainable energy. Number 2. The strange energy coming from Voyager's edge. Although the mission of NASA's Voyager 1 probe at its launch in 1977 was simple, limited to exploring the outer planets and then drifting into interstellar space, what was unexpected was the spacecraft's continued transmission of signals and data decades later, surpassing all technical challenges. Once Voyager crossed the boundary of our solar system, known as the heliopause, its instruments began to detect unique phenomena. It observed a region of extremely high temperatures in the vicinity of the boundary, an increase caused by the pressure of charged particles at the intersection of the interstellar medium and the solar wind. The spacecraft also began recording a low-frequency hum, which was confirmed to be faint, persistent plasma waves emanating from the local interstellar medium. These readings have allowed scientists to measure the density of interstellar plasma accurately and continuously, even in the absence of powerful solar flares. Furthermore, Voyager recorded peculiar magnetic readings, where scientists noted that the change in the magnetic field's direction was not entirely as anticipated upon crossing the boundary, suggesting that the region beyond our solar bubble differs from what models had assumed. The mission team described these phenomena as unexplained plasma interactions in the interstellar medium. The data confirms that Voyager is currently swimming in a region where electromagnetic fields and plasma interact in ways they did not fully comprehend initially. In conclusion, Voyager 1 is not only exploring space, but is providing direct data on the physical conditions outside our sun's sphere of influence, helping scientists update their understanding of the interstellar environment and revealing more about the boundaries of our solar system. Number 3. The particles that act like they're from another universe. In 2020, NASA's ANITA experiment, a high-altitude balloon project flying over Antarctica, sparked global astonishment due to an observation that contradicted standard physics principles. Instead of recording the usual cosmic particles descending from space, ANITA picked up what appeared to be signals from high-energy particles emerging and descending from deep within the Earth. This observation is considered impossible under current physical understanding. Powerful cosmic particles, such as ultra-high-energy neutrinos, should interact with and be absorbed by the planet's mass, preventing them from passing straight through. Despite this, ANITA observed neutrino signals coming from below, in stark contradiction to particle-matter interaction expectations. After careful data and instrument reviews by NASA scientists, the validity of this experimental anomaly was confirmed. This phenomenon, officially known as unexplained high-energy neutrino events, has opened the door to interpretations that go beyond the conventional. Radical suggestions included the idea that the source of these particles might be a parallel universe where known physical rules, such as the direction of time, are reversed. More conservative explanations hypothesize that this could be the first indicator of new, undiscovered elementary particles that interact with gravity and space in ways our current physical model cannot explain. Other experiments have also supported the observation of similar anomalous cosmic particle events. If interpretations that exceed the scope of the standard physical model prove correct, Anita's discoveries could represent definitive evidence of new, unexpected physics, or perhaps, as some speculate, a visitor from another universe. Number 4. The object that spins forever almost. In 1972, NASA launched the Pioneer 10 probe, the trailblazer that would cross the asteroid belt. This metallic time capsule is now adrift in the depths of space. Its theoretical trajectory launched based on precise physical calculations accounting for speed, fuel consumption, and acting forces. We were confident in our predictions. But decades later, scientists revealed a baffling anomaly. The probe was slowing down at a tiny yet constant rate, causing it to deviate from its predicted position and challenging Newton's laws of motion. This deceleration could not be explained by any known force, such as solar pressure, cosmic dust, or gravitational pull. Adding to the mystery, Pioneer 10's rotation refused to decay as expected, continuing to spin as if ignoring the law of conservation of momentum. NASA engineers pored over the phenomenon, developing models and simulations, even calculating the thrust from the heat emitted by the spacecraft's antenna. Although the stream of light photons could explain a fraction of the thrust, the numbers remained mismatched. The data indicated a small, constant drag force from behind, as if space itself was applying a hidden brake on the probe. The matter wasn't limited to Pioneer 10 alone. Similar effects were observed in Pioneer 11, Ulysses, and even New Horizons, where each acted slightly contrary to physics predictions. It seems as if something is rewriting the simplest rules of motion, rules we thought had been firmly established since the time of Isaac Newton. Today, more than 12 billion kilometers away, Pioneer 10 is headed toward the constellation Taurus. Although its transmitter is silent, its strange journey continues to haunt the scientific community. It is a silent cosmic witness, evidence that a hidden force might bend the equations even in the vacuum of space. Perhaps the lesson is that the universe is not obligated to provide easy explanations.